Hi guys, today we start in our neetcode and we will try to solve neetcode for 60 days. So let's try our best efforts. So I'm sharing my screen. 30 minutes. So let's go with the first one. Okay, so we have easy question. We given an array of integers and lengths n. You want to create an array ans with length 2n, where ans I is equal to nums I, and ans I plus n equals to nums I. Okay, so let's try first to analyze the question. So first one, we are given an integer array nums of length m, right? So it's some integer array. So let's say 5, 6, 2, and we have length 4. We want to create an array ans, so we want to create another array that would be 2n. So here we will have 8 values, right? So let's go 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So we have seven values where ans I equal to nums I, right? So here it's equal to 1, and I plus n equals to nums and I plus n for I less than n. Okay, so it's specifically 0. So let's go. So let's try to analyze the problems, because I think I didn't understand this. So we have, for example, 1 to 1. So the array ans. Okay. So we want to make like this. So we want 1, 6, 2, right? And here also 1, 4, 6, 2. So we want like to double this array. So what we can do, it's actually we definitely need to, so what would be the approaches here? So approaches would be the following. So before starting this, let's go to the framework of how to solve the problem. So framework would look like this. So first we need to read and understand the problem. Second, we need to define a statement. Third, we need to propose test cases. Fourth, we need to propose approaches. 5, we need to tell about trade-offs of each approach. Then we need to tell about time-space complexity. Then we need to implement. 8, then we need to debug. And 9, refactor if needed. So we have 9 steps that we need to do. So first step we done, so we understand. Then we define the step and we done. Test cases we also done. Approaches, so let's think about approaches. So the first approach that I see, we create array and and just do +2 loops. First loop is going from 1 to n, and then plus n to another one. Can we do, for example, in one loop? I believe yes. So we can just iterate with mod. So let's try with one loop. So here it would be mod. And I don't think that we have here more optimal approach. So let's see what would be the time complexity. It's n. Space complexity we create also another array. It would be 2n, because we don't modify our array. Trade-offs, we don't have any trade-off. I think this approach is the most optimal one. So let's go to implementation now. So I will create our result array with nums length multiply by 2. And then I will just iterate over our array res length. And we already have like our results that we need to have here. So we have nums I mod, right? Mod like this, nums length, and we return result. So let's debug this code and let's check if it works. So as I told, let's take this as an example. So we created a new array with all zeros. So I will just empty. Then we just iterate. So we have first one, right? So we iterate with 0. So we try to put one mod. So the n would be here 4, right? Because length of 4. So one mod 4, it will be 4. The 0, sorry, yeah, 0. Then 2, 1, 2, 3. When it's 4, it's going back to 0. So I think it should work. So let's run it. And let's submit. Yep, okay, so it's 96%. Let's check in which case, yeah. So it's more optimal if you do a system copy of these two arrays, but you still need to implement. So we can mark this as done, and we spent 7 minutes. So let's go to the next one. Okay, well, let's do like this. Contain duplicates. So let's start with our approach. So first, read. Given an integer array, return true if any value appears at least twice in the array, and return false if every element is distinct. Okay, so it's pretty understandable question. Then we need to... So after reading, we need to make our statement. So first, each statement. So we receive array, we need to return true or false. Yeah, okay. Let's think about use cases. So first use case, it's empty array, and let's think about also constraints, because here I think it's important. So I would suggest that we also have an empty array. So if it's empty array, then it's true. And let's say that we have 10 in 6 elements, and also we can have array values. It's like, let's say, int values, right? So to make it more simpler. Use cases. So for empty array, it's true. For array with one element, distinct, it's also true. So we can just make it like this. Then for this distinct, it's true as well. If we have something like this, it's actually false. All right. Let's think about approaches that we can use here. So the most optimal approach is, of course, it's use a hash data structure, and we put every element in our hash data structure, and if it's false, we just return false. So in this case, time complexity n, space complexity is also n. Let's think about another approach. Another approach, we can use 2 loops here, and time complexity increase to quadratic time, and space complexity would be constant. What else? We can, for example, sort our array. So here, time complexity would be a little bit better, and log n, because we sort, and then we just iterate one time. Its space complexity would be also 1. It depends on the sorting algorithm, but yeah, in general, it should work like this. So can we do something else with a linear space complexity? and a constant space. Let's think. I'm thinking now about maybe XOR operation, because what does it mean XOR? So we have binary operation, right? XOR operation, it means when we have 0 and 0, it would be 0. When we have 0, 1, it would be 1, right? 0, 1, 1, 1 is 0, if I'm not mistaken. Let's quickly check XOR operation. And let's check images. Yes, so we see that XOR it's indeed like this. So what does it mean? It means if we have 4, let's say we have some value like this, right? And value like this. So here we see like 1, 2, 4. So it's 6, right? And here we have 1, 2, 4, 8. So it's 9. Yeah. So we have 6 and 9. And when we do XOR operation, here it would be 1, 1, 0, 0. So we receive 1, 2, 4, 8, 12. So we don't need it. But if we do like XOR for the same, we actually receive all zeros when we do XOR. So at some point in time, we should return 0. But what if we have like multiple such values like 2, 4, 6, 7, and 2? So when we do 2 and 4, it would be some new value. And then with new value, we do this one. So I'm not sure that XOR will actually work here. What if we do kind of, not XOR, maybe some other, and it means like, yeah, if it's equal, then it would be 1, something like this. It would be 1, and then, yeah, I don't think it would be also like this. Yeah, I think from this one, the most optimal would be hash data structure. So let's quickly solve this with hash data structure. So I will take this approach. So let's implement new hash set. So we have set of integer, and then for int nums, if s add n it's false, we return false. Otherwise, we return true. So it's pretty much simple one. So we just run and submit. Let's check. It's false. Why? So we have n, we have s when we add our n. And if we cannot add, we return true. We return false. Contains, so otherwise. Yeah, sorry. And submit. Yes, we see that something like this. Let's check some other operations. Do they have something? Okay, so hash set. Okay, this one is interesting. Approach 1 optimal using hash set. Finding the number while sorting. Okay. Insertion sort. So it's another approach. previous index. We try to find, so here they do insertion sort. Here, I think it's also insertion sort. Let's check maybe tutorial. No, solutions. Okay, so I think hash set would be the most optimal here. Let's go to the next one. Let's check valued anagrams. Let's clean up this one and let's go. Okay, so we are given two strings, anagram and nonagram. We should return true if t, so we have string s and t, we should return true, false. So given string s and t, return true if t is an anagram of s and false otherwise. What does it mean, anagram? An anagram means, as an anagram is a word or phrase formed by rearranging the letters of different words or phrase using all the original letters exactly once. Okay, so here, what is important to say? Here is important to say S and T lengths. So I could say that, let's say that they also could be empty, and the maximum, it would be, 6. What about values? Can I say that it's all only lowercase letters? Yes. So it's only lowercase English letters. And if it's lowercase, then it becomes very simple. So let's imagine that we have AB and we have BA. So in this case, we should return true. What do we have? ABB and BAB. So we also should return true. What do we have? ACC, but here we have AC, so it's like two different lengths. So this would be edge case for us. Then ACC, but here we have ACB. So it's the same length, but it's different words. Okay, so let's think about approaches. So the first approach that I see is that if it's only English level letters, so we can just create an array of 26 positions and then increase the counter of the first string and then just iterate over second string. And if we have some value and this value is equal to 0, then we just return false. Otherwise, return true. So like array with counter and plus 2 loops. So here we have time complexity n plus n, and it's actually the same, should be the same n. So it's like n because it's 2n. So it's n, and space complexity we don't, we create our array, so it would be n. It can be not n because here we can have duplicates. So it's 26. It's constant because it's like we know that it's like constant array. So we can even do not count it into our approach. And I think it's quite optimal one to have a linear solution here. So let's go to implementation. So as this tool, we have our array. It would be our memo. Then we iterate over each character in string, first string. Then we have our array. We have we have our incrementation here. Then we have another array over t, and if array if array c let's do here more complex one. So we first do like this. So we decrease, and then we check. So if this value is less or equal to 0, or is less than 0, then we return false. Otherwise, we return true. Okay, so here we create array, then we populate this array with with our values. Then we iterate over the second array. We decrement these values. If we see decrementation less than 0, we return false and return true. So I think quite straightforward. So let's run. Yes. And submit. Yeah, so what I forgot the main edge case. So you see, I didn't run dry runs, not dry runs, but debugs, and I see that I missed like the main use case here. And we see like 91%. Let's check some other solutions. Yeah, pretty much the same. And here, yeah, here pretty much the same, I think. So we can say that we actually solve this problem. So let's go to the next one. So here is a classic two-sum problem. Let's try to solve this two-sum problem. So first, let's read the definition. We are given an array of integers nums, and in integer target return in indexes of the array numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Okay, so I understood. So we have, so second is statement. So we have an array, and we also have some integer, let's say target. And our result, we should return an indexes of I and j, where two values, right, of this array would return as result. Okay, so let's think about constraints. Okay, so our array, do we actually interested in our lengths? So I should suggest that we have at least 2 elements right here. And here, let's say we have 1 million elements. Then I could suggest that, can we have like negative values here? Generate integer, return the 2 numbers should. Yeah, I could suggest that it could be any integer without overflows. It's important to say. Also, we have target. So target, let's say it's also like integer value. So we have negative and positive, right? So I believe that's pretty much the same, all that we need to get here. So let's think about test cases. So first test case, when we have target 3, right? So there's exactly one solution, so we should return this. So we have 3. So here it would be 0 and 1. Yeah, pretty much simple one. Then we have 1, minus 2, 0, 2, and then we have 4. And we should return 3, for example. So in this case, we have 1 and 2, and that's it, right? So it would be 0, and 1, 2, 3, and 3 as a result. Okay, so from test cases, I pretty much understood what should we do. So let's think about approaches. Okay, so the first approach, I think that is the most simple one. We can have kind of a map structure where we have value and index, and then we just iterate over our array, and check if we have in map this value, like target minus current value. We have this value, and just return a current index and this index. So the main problem here is that it can be like duplications, but given a read and to number that target, you may assume that each input would have exactly one solution, and you may not use the same element twice. So we should just get. I think we cannot use the same element twice because it's currently not put into the map, right? So I believe we have this constraint here. So time complexity would be n, space complexity would be also n, because we populate this hash map. The problem with other approach is that we still need some sequence, so we cannot sort this array, and also we cannot create an array. Like map is more efficient because here we have transpolation of any integers, like the big variations of integers. So we definitely need some more efficient data structure here, and map I think is the most optimal one. So when we find let's then start with implementation after our approach. So as we said, we need hash map. So it would be map with integer and integer map. Then we just iterate over our array where we need our index actually. So we iterate nums length I++, and here we check if map get, and we can make contains target minus nums I. It means we have this. We can return a new int of map get this value and current index. Here we should never go, so let's return null from here. And if it not contains, then we just map put our nums I and I. So I think something like this, but yeah, let's debug this code with, for example, we will take this as an example. So 7, it's debug. So let's take this example. So we have our map that would be like empty at the beginning. We have iteration. So we check, okay, target 9 minus not nums I, yes, nums I, because minus 2, right? So 9 minus 2. Does it exist 7? It doesn't exist, so it's null. So we just put here 2 and 0. Then we go to 7. 7 minus 9. Does it exist 2? Yes, it exists. So we just return. So here it's pretty. It's correct one. Here it would be. So with this one, we have 3. So we put first 3, then we put 2, then we put 4. 4 it's 2. So we return 1 and 2. What if we have, we can have duplicates, okay. So we have 3, then we have another 3, and we return the current value, yeah. Yeah, because we first put, so we just return. So I think it should work, so let's go. Map contains keep, it should be like this. Yes, and submit. Okay, and we are done. I think it's the most optimal one, and we can check editorial. Yeah, with map, it looks pretty the same. Even in our implementation, it's easier. This one, yeah. One pass hash table, yeah. So it's most optimal one. And that's it. So thank you very much for our first day, and let's see you the next day.